Let's talk about electric power here really quickly. So, if you remember back from quarter one, quarter three for us, power is equal to energy divided by time. And so, if we put that in equation form, we get P equals E over T. Also, remember on Monday, we learned that voltage is equal to energy divided by charge. So, if we take the voltage equation and rearrange it, we get that energy is voltage times charge. Now let's take this energy and substitute it up into the power equation, and we will get, in this case, power is equal to voltage divided by, or voltage times charge divided by time. But what is charge divided by time? We also learned on Monday that that is current. So what we wind up getting is this: power is current times voltage. And written in equation form, it looks like this: power equals I times V. This will be our main equation for power when we do electrical problems. And so focus on that one. There's a couple others, though, that we can get. If we take Ohm's law in this form, voltage is current times resistance, and we plug that in for voltage here, we get I squared times R. Or we could take Ohm's law in this form: voltage divided by resistance is current, and substitute it in for that current, and we get power is voltage squared divided by resistance. So those are the three different power equations that we can use in this chapter, or this will be the main one up here. Remember, the unit for power is the same as it always has been, which is a watt, and that's what we used before, and it's still the case now. So let's do a couple of quick examples here. What is the power of a blender that draws 2 amps if it's connected to 120 volts? Well, bring up our power equation here and plug in. Current is 2 amps, voltage is 120 volts, so just multiply those two. The power of a blender then would be 140 watts. So let's look at a second example here. How much current does a 1,000 watt microwave pull from a 120 volt line? So use our equation: power is current times voltage. Plug in power is 1,000 watts. Voltage is 120 volts. Solve for current by dividing the power by the voltage, and we would get 8.3 amps would be the current there. So the power company like Duke, they keep track of something called a kilowatt hour you use, and they charge you by that thing called a kilowatt hour. So what is a kilowatt hour? It's a big old chunk, a unit of energy, and it's equal to 3,600,000 joules. You'll use maybe 100 kilowatt hours, so you can see why they charge you by the kilowatt hour instead of joules. And when I say when you might use that, that's over the course of a month in which they'll bill you. So you would have millions and millions of joules, and that's why they don't use that, and they use this thing called a kilowatt hour. Somewhere on the side of your house, there'll be this little electric meter, and you'll see that it's stamped on the side, kilowatt hours right there. So, and people used to actually come to your house and physically read it, but now it's all done wirelessly. So let's do one of these problems here. If power is equal to energy divided by time, then energy is equal to power times time. If you plug in watts in your power and your time in seconds, then your energy answer is going to come out in joules. But if you plug in kilowatts for your power and hours for your time, then your answer is going to come out in kilowatt hours, which is what we want for one of these cost problems. So let's say you have a 200 watt heater. It's running for 10 hours. The power company charges you 10 cents per kilowatt hour. Let's use our power equation in this form. So power times time. 200 watts converted into kilowatts is 0.2 kilowatts. To get that, you divide by 1,000. So take your watts, divide by 1,000 to get into kilowatts. Our time is in 10 hours. So 0.2 times 10 is 2 kilowatt hours. That's how much energy you used. If they charge you 10 cents per kilowatt hour, then we multiply the two. So 10 cents times 2 kilowatt hours would be 20 cents would be the cost that they would charge you there. And that is the end of the power video.